When we take a look at the selection criteria for LAN technology, there has to be some sort of criteria, and some of the things we're going to look at is the number one question a network engineer asks when I say, build me a network. They say, okay, what applications do I have to support? That's the number one thing I need to know. If I'm going to do a lot of voice over IP, I got to design one with low latency so that the phone calls come out crystal clear and sound really good. So that means I'm going to ask questions like, how much bandwidth do I need? What area needs to be covered, and what are the physical constraints, right? How big is this network? Where's it going to go? First floor, second floor, next building? What's my budget? Do I need remote management? What are the security needs I need to have? And what type of redundancy, resiliency do you want? Now, in a wide area network, that's a communications network that transmits information across a geographically dispersed set of local area networks. That's what I've said before. Your characteristics is that they still work at the physical and data link layer of the OSI model. They still follow that paradigm. But for the most part, they work at layer 1 and 2 and layer 3. The data flow can be simplex, half duplex, or full duplex. Okay, simplex means one-way communication. What's that example? You ever listen to the radio? Right? Turn it to your favorite FM station. That's a simplex. I mean, you can yell and say how much you hate the song, but they don't hear you. They're transmitting to you one way. Half duplex would be a CB radio, walkie-talkie. I can talk or I can listen, but I can't do both at the same time. And then full duplex would be more like your telephone. I can talk and listen at the same time, right? Transmit, receive simultaneously. Your communication lines can either be going through a switched network or a dedicated network. The difference is, and I like to use from one of my old favorite TV shows when I was a kid, Batman. I'm talking 60s Batman, right? And Commissioner Gordon had a phone, and he'd pick it up, and it automatically rang at the Batcave. That was a dedicated line. Some people called it a ring down line. Now, a switched line is the other telephone. I pick it up and I hear a dial tone. I don't hear Batman answering the phone. I have to put in a series of phone numbers, and based on the phone numbers that I enter, that's when the connection will be made. They call it a switched connection. So those are the kinds of communication lines you might have. Now, there are many emerging trends that we see today that are kind of going away from these models of switched and dedicated, becoming dedicated connections, but we're using different types of layer 2 protocols. Basically, here's the story. Ethernet services is taking off. I mean, it's red hot. I'm going to service providers and large corporations and small corporations, and we're ripping out old frame relay and AT, and they're putting in Ethernet services. They want their Ethernet connection to go 20,000 miles, and why not if it can do it, and still have that high-speed connection. That's great. That's another emerging trend that you're going to probably look at as you're doing your evaluations. When we talk about the different types of transmissions, I just kind of gave away some of this with these different types of switching models. So packet switching, well, you have message switching, which is old, and we don't use it anymore, so I'm not going to really talk about it too much. But packet switching was the use of the dedicated line. Examples of that packet switching is things like frame relay. And I see a few publications that do say ATM falls in that category, but a lot of people called it cell switching as well. X25 is here, but that's a predecessor to frame relay. And what happens is here's my LAN, and here's my branch office, and maybe I have one of those small home offices down over here. So I'll make it look like a house. This is a branch office. And I got my headquarters LAN. And so what I do is I pay my service provider. That's who this is, my service provider, to give me a connection so I can get from headquarters to that branch. And so they would, I would enter their cloud, and then they would make a permanent virtual circuit to some other switch at the other side of the cloud so I could get to that branch office. And they'd make another one so I could get to that Soho. And that's what we did at packet switching. We had permanent virtual circuits. The bat phone. So remember, packet was IP address, right? So I send a packet with an IP address, and this device, actually, to tell you the truth, it was frame relay and ATM, really didn't care about the ultimate IP address. It used connection identifiers that I'm not going to get into all that. One's a data link and one's a virtual. Anyway, it would have a way of identifying which path to take, and that's like great. Now the circuit switching. Remember, it's a little different creature, I said. Circuit switching, and the best example I can give you is the Integrated Services Digital Network, ISDN. There, I still wanted to get to an IP address, but I had to put in a phone number. Literally, a phone number, a circuit identifier. And once that phone number was received, then this guy could do a lookup and figure out who it wanted to send it to. And that was not a permanent virtual circuit, so they called it a switched virtual circuit. And all a virtual circuit is a path. A path through the service provider network, as though you thought it was your own private network. We also had the old days where you could go through the publicly switched telephone network, the PSTN, and use your really high-speed 56K modems to make your connections. But you know what? That was still a service provider.